Hello, Fang here again, and I want to go over chemistry final review, I guess, and I hope this will help you, whoever's watching. And alright, this is for chemistry for high school AP. Okay, I might not be 100% right on the topic, but it should be similar. Okay, let's start the reaction first. So this reaction called synthesis. Basically, it's combining of A and B. So A plus B equals AB, basically like that. That's why I call it synthesis. The decomposition is too long, so I just decomposition. Basically, the AB breaks into A and B, A plus B. Okay. Combustion's a bit tricky now. Okay, combustion basically is one mole of the substance A plus how many mole of oxygen is needed to make hydrogen, to make water and CO2. So basically, a mole. Only a mole, so one mole of this, and however many mole of oxygen to make H2O and CO2. Okay, now we're down to redox. Redox basically, here's some rule I listed. You should remember. Oxidation of H with nonmetals. So oxidation of hydrogen with nonmetal is +1 always. Oxidation number of oxygen is 99% -2. Except when it comes to H2O2, where oxygen's oxidation number equals to -1. Okay. The oxidation number adds up to equal the charge of the substance or the molecules. Let's say, let's say CO2. So CO2, oxygen, we know it's always like -2. So we know that's in total that'll be -4 because it's within each atoms. So you have 2 atoms of oxygen, and each atom is -2. So you get -4 oxidation on the oxygen, and you have a carbon here. But however, there's no charge, so the carbon must be +4 oxidation number, and simple as that. Okay, now let's move on to balanced redox. Okay, so first of all, we should remember these three. I would say compound ion. Okay, one's MnO4 minus. Second is Cr2O72 minus. Third is HNO3. Okay. And we should also know what do they become. So MnO4 minus in a redox reaction, they become Mn2 plus. Cr2O72 minus in a redox reaction, this one becomes Cr3 plus. I hope I'm correct. Okay. On HNO3, this one in a redox reaction most likely becomes NO2 or NO. Depends on what's the redox reaction with. Okay. I wrote down the step to balancing the redox reaction, so it'll be here. Half reaction, right half reaction, balance the atoms, balance oxygen with H2O, balance hydrogen with balance hydrogen with H plus, and balance charges by adding electrons on more positive side. And 6, the last step will be adding the equation together and cancel the electrons. Okay, let's start from here. So I have a K2Cr2O7 plus Cu. From this, the oxidation of Cu, because it's in elemental state, is 0, and so they must undergo a redox reaction. So from that, I know Cu goes to 2 plus. Okay, so I write down the half reaction right here, Cu plus 2 plus. Cu goes to Cu2 plus. And Cr2O72 minus equals 2Cr3 plus. And remember the steps, we balance oxygen with H2O. H2O. So plus 7 H2O. And then next step is balance hydrogen with H pluses. So I will plus 14 H pluses on this side. 14 H pluses. And then 7 H2O. And next, you want to balance charges by adding an electron on more positive side. So right here, I have 14 positive charge here and 2 negative charge here. So I have a total of 12 electrons here. And right here, I have 3 and 2 of the 3. So I have 6 electrons here on this side. So here's way more positive. So I would add enough electron to make it equal to 6. So I add 6 electrons. Yeah, because here's -2 and here's 14. So you have to subtract those, so I will have 12, because this is positive charge and negative charge, so okay. And then, now that they're balanced, you move on to this one. So there's no oxygen on this side, I can balance with hydrogen, H2O. And there's no H2O on this side, I can balance with H+. Now we only need to balance the electrons. So right here, I will add 2 electrons. Because here's 2 positive and here's 0 here it's 0 charge. Right here it's plus 2 charge. So I need plus 2 electron to cancel out the charges. And then now we add the equation up. We add these 2 equations up. So I have, make sure you want to cancel the electron, right? Stay on opposite side. So 6 electron on the reactant side and 2 electron on the product side. So I want to multiply by 3 on bottom. So I get 6 electron here, so I can cancel out with this. And then I will left with 14H plus Cr2O72 minus plus 3Cu. 3Cu goes to 3Cu2 plus 2Cr3 plus 7H2O. You guys got it? And that should be your final answer, I believe. Yes it is. Okay.
Implant company in the nation. It was very successful and I sold it.
Okay guys, so let's talk about gas forming reaction now. So I have metal oxide equals base, non-metal oxide equals acid. Metal oxide plus acid equals acid and base reaction, okay? Metal oxide plus non-metal oxide equals acid and base again, okay? And non-metal oxide plus base is equals acid and base reaction also, okay? You gotta remember, gas forming reaction is not a redox reaction, okay? And right here it's these two you must know. Any carbonate plus any acid equals, it must have a product of CO2. And any sulfide plus any acid, you must have a product of H2S. Okay. Now we need to know some strong acid for the test. So the strong acid you need to know be HCl, HNO3, and HSO4. And as well for the naming of acid, whenever you have an ATE, it turns into IC. And when you have an ITE, it turns into OUS. Okay. For the base, you might want to know NaOH and MgOH2. That's the strong base I remember. For Lewis structure, you guys might not have it, but we took it last year and it was in the first semester final. So basically, the donor is a Lewis base. The acceptor is a Lewis acid. Okay. Electrolytes, the example would be NaCl in water. Basically, electrolyte dissolve and it turns to a good conductor of electricity. And non-electrolyte is things that does not ionize, whatever. But yeah, just don't break apart like NaCl. Okay, next one will be... Okay, next one will be thermal. And you should know this formula, K equals 1 over 2 mv squared. No, KEQ equals 1 over 2 mv squared, which is kinetic energy. Okay, so basically temperature equals average, from temperature you can find average kinetic energy of the molecule and such. And we should also know that heat energy does not equals temperature. Here's a graph of the, of let's say ice or water. 0 degrees Celsius. Okay, that's a 0 degrees Celsius. SH means specific heat, which is energy required to raise temperature and change slash delta G. Okay, and latent heat basically is energy required to change phases. Oh god, phases, shape or whatever phases. Phase. Example would be liquid to gas, and no temperature change. Okay, so basically this graph it shows that this one, SH, specific heat, right here, there's no phase change, only temperature change. And right here, latent heat, there's phase change, but no temperature change. And here's again, here's again, here's again. Okay. And right here will be the graph of a reaction. This will be the reactant, this will be the product. If the product's energy is below the reactant, you would know it's endothermic because delta H will be positive. And I look at the bond. How do you solve? I look at the delta H solve from bond, which should be delta H equals reactant minus product. And right here, reactant is higher than product, so delta H must be positive. So I label this as bond energy. But in general, if delta H is positive, it should be endothermic. endo, and then when delta H is negative, it should be exothermic. Okay, let's talk about heat of formation. Delta H equals delta H product minus delta H reactant. The heat of formation comes from the formation of 1 mole of substance from elemental state. So basically, 1 mole of this minus 1 mole of this. But for the equations with more than 1 mole, we just multiply the formation value with how much the coefficient of that substance. And we need to remember KEQ is also affected by temperature, always. And now let's talk about pH, KEQ, and Q. So here will be my simple equation, and right here will be my Q. Because of here, it doesn't represent it. It can be a backward reaction also, so you must label Q. You do not label KEQ. Okay, from delta G gives free energy, you can solve for KEQ. From electric, you can also solve for KEQ. And when you're given kinetic, you can find the rate. Okay, so at delta G, it doesn't have the circle on top, so right here we call it delta G naught. Right here we call it delta G. Okay, when delta G goes 0, it's at KEQ. So right here is the equation: delta G equals delta G naught plus RT ln Q. Okay, so the Q you will get from here, and you can solve for it. Then here will be NFE equals NFV naught minus RT ln Q. So the N here stands for mole, F equals Faraday's constant, which would be 96,485 coulomb per mole. Coulomb per mole, okay? Okay, so KEQ, the definition of KEQ is where the rate forward equals the rate backward, and had to be a reversible reaction. Okay, vapor pressure, which we'll be using in KEQ soon, goes to ATM, which happens at boiling point, basically, or like how much of molecules in the atmosphere, or the pressure, basically. When doing KEQ, if you see solid equals going to ion, becoming ion, it's KSP. When acid or base or any of them becoming ion equals KEQ. Okay, and for the molarity of solid and liquid, we always label 1. Okay, right here be the K value for reaction A, K value for reaction 2, so A plus B equals C, well C plus, oh my god, not C, let's put E, oops, labeled it wrong, but yeah, let's say E plus D equals F, so A, B, if you add them together, so A plus B plus C plus D equals C plus F, you multiply the constant value, so the K from K1, the K from K2 equals the K3, which would be this reaction. Okay, now let's talk about gases. In gases, KEQ equals KP, which is pressure, and PV equals nRT. We all know that formula. Okay, so right now I divide the V onto the other side, so P is by itself. So remember, mole over volume equals molarity.
Simplify that to be P equals molarity RT, and right here KP divided by KP divided by RT equals molarity. KP stands for pressure, and basically a KP, if you find the molarity, you could plug it in, and you could easily find a KP. Basically, if you find the molarity, you can find a KP, or if molarity is given, you could easily find a KP value. Now let's talk about titration, which will also, I would think, a few questions on the exam. When titration basically is acid and base reaction, but it's a weak acid plus a strong base, or a strong base plus a weak acid. But in all the cases, Ka times Kb is always 1 times 10 to the negative 14. POH plus pH equals 14. pH is solved by negative log molarity of H plus. POH equals negative log of OH minus. Right, here's the equation for the titration. Delta H equals Ka molarity of HA over molarity of A minus. This formula is derived from the KEQ formula, which is Ka equals delta H delta A divided by delta HA, or not delta, my bad. Ka equals molarity of H plus and molarity of A minus over molarity of HA. And right here, I drew a graph to represent the titration curve. Okay, at the midpoint, which is here, H plus equals Ka. Molarity will be 0.5 over molarity 0.5. Because at midpoint, enough of HA dissociate to make the half of HA dissociate to make A minus, and since you dissociate half, so I would label 0.5 over 0.5 because of this formula. So you know this is like, let's say it started 1 and dissociate half, and this gains half. In the beginning of the point, there's none that's A minus. So at midpoint, this would gain 0.5. At midpoint, this would minus 0.5. So 1 minus 0.5 over 0.5, that equals 1. So at midpoint, Ka equals HA. Okay. And remember, at endpoint right here, or equivalence point, I call it endpoint. We must use hydrolysis to find H plus, because at this point, the value just increased dramatically, and also at that point, there's no more HA, and it could be because this is a reversible reaction also. So once you reach endpoint, so all the HA dissociated, it doesn't mean that HA won't form back right here. So we must use the hydrolysis reaction, which also you have to use the ice formula or the ice box to solve for the H plus in the end. And this should be helpful, I hope. So basically, just go over all the formula and how will you do some of the problems, and you should be fine for the final, I would say. Since the final at my high school is mostly multiple choice, so you guys should be fine. Alright, thank you.